Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topic of this video is planetary gears and hydraulic multiplate clutches. The contents are planetary gears, hydraulic multiplate clutches, types of planetary gear, and applications of planetary gear. In automobiles, planetary gears are used extensively in various components such as step-type automatic transmissions, CVTs, differentials, transfer in 4WD vehicles, reduction gear in electric vehicles, large truck axle reduction gears, and starter motors, among others. A planetary gear consists of three components: an internal gear, a sun gear, and a planetary carrier. The internal gear has teeth on its inner circumference located on the outer side. The sun gear is at center. The pinions connect the sun gear and the internal gear, and the planetary carrier assembles the pinions. The pinions rotate individually and also rotate together with the planetary carrier. Let's try applying the brake to the internal gear to prevent it from rotating, and applying an electric motor to the sun gear shaft for input rotation. The input rotation speed into the sun gear is reduced, and then output from the planetary carrier. When the electric motor is applied to the planetary carrier, the input rotation speed into the planetary carrier is increased, and then output from the sun gear. Next, let's apply the brake to the sun gear to hold it in place. The input rotation speed into the planetary carrier is increased, and then output from the internal gear. The input rotation speed into the internal gear is reduced, and then output from the planetary carrier. Lastly, let's apply the brake to the planetary carrier to hold it in place. The input rotation speed into the internal gear is reversed and increased, and then output from the sun gear. The input rotation speed into the sun gear is reversed and reduced, and then output from the internal gear. Let's try thinking of this planetary gear as a transmission. Attach the tires to the internal gear, and install an electric motor on the planetary carrier in place of the engine. Due to the friction between the road surface and the tires face significant resistance, so when the planetary carrier is rotated with the electric motor, the sun gear will rotate idly. When a braking force that is greater than the resistance on the tire is applied to the sun gear to hold it in place, the internal gear and tire rotates, allowing the car to start. When the braking force is slightly reduced, the sun gear rotates slowly, and the rotation speed of the internal gear is reduced. Further reducing the braking force causes the sun gear rotation speed to increase, while the internal gear rotation speed is reduced even further. The gear is held in place by a hydraulic multiplate clutch. A hydraulic multiplate clutch consists of an inner shaft with grooves on its outer circumference, an outer shell with grooves on its inner circumference, and clutch discs that engage with each groove, and a pressure plate that exerts pressure on the clutch discs. The clutch discs engaged with the inner shaft can slide in the axial direction of the inner shaft, and rotate together with the inner shaft. The clutch discs engaged with the outer shell can slide in the axial direction of the outer shell, and rotate together with the outer shell. When the clutch is not engaged, the rotation of the inner shaft does not transfer to the outer shell. When hydraulic pressure is applied to the pressure plate, it pushes the clutch discs to produce frictional force. Then, the inner shaft and outer shell rotate together. Let's try installing a hydraulic multiplate clutch to a transmission. The outer shell is fixed to the transmission case, and the inner shaft is attached to the sun gear. When hydraulic pressure is not applied, the sun gear can rotate. When hydraulic pressure is applied, the outer shell and inner shaft are engaged, and the sun gear does not rotate. This is referred to as the sun gear being held in place. Similarly, the hydraulic multiplate clutch is connected to the sun gear and planetary carrier. When the clutch is disengaged, they rotate separately. When the clutch is engaged, the sun gear and planetary carrier rotate together as one unit. The double pinion planetary gear utilizes 4 pairs of pinions. 4 inner pinions are engaged with the sun gear. Each inner pinion engages with an outer pinion. The inner and outer pinions are connected to the planetary carrier. The outer pinions are engaged with the internal gear. It has a larger reduction ratio compared to the same outer diameter single pinion type. Similar to the single pinion type, it combines input, output, and hold elements. This chapter will show 2 examples. When the planetary carrier and sun gear are connected, all elements rotate as one unit. The input rotation speed into the sun gear output from the planetary carrier with same rotation speed. When the brake applies the internal gear to hold it in place, the input rotation speed into the sun gear is reversed and reduced, and then output from the planetary carrier. The Ravigno planetary gear consists of 2 sun gears, a planetary carrier with 2 pinions, and an internal gear. There are 2 separated sun gears. The smaller sun gear is engaged with 4 inner pinions. The outer pinions are engaged with the larger sun gear, and also they are meshed with the inner pinions. The inner and outer pinions are connected to the planetary carrier. The outer pinions are engaged with the internal gear. It has more components than a typical planetary gear, resulting in a greater variety of input and output combinations. In step-type automatic transmissions, 2 to 4 sets of planetary gear set are used in accordance with the number of steps of gear, combined with hydraulic multiplate clutches. Depending on the transmission model, it adopts double pinion type or Ravigno's planetary gear. The forward and reverse changeover mechanism of the CVT employs a double pinion type planetary gear. During forward, the sun gear and planetary carrier are engaged, allowing the input rotation to be directly transmitted to the output. During reverse, the internal gear is fixed, causing the input rotation to be reversed and transmitted to the output. Due to planetary gears can increase and reduce speed coaxially without occupying much space, they are employed in the reduction gear of small battery EV motors. For the same reasons, they are also utilized in the reduction gears of starter motors, and axle reduction gears in large trucks. The characteristic of changing the output rotation speed based on the resistance force applied to each element is utilized in Toyota's hybrid system, differential between driving wheels, and the center differential in 4WD vehicles. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.